Hello, all. Let's continue our discussion. So, from a previous discussion, we understood the problem we have with the data lake. So, with data lake, we can only do read-only transactions. So, in between this compute engine and storage, we have this Hive metastore, which gives the abstraction to identify data which is stored in this data lake in the form of tables. So, if you replace this Hive table format with the modern table formats like Apache Hoodie, which is a table format, or a Delta Lake in another table format, or with a table format like Apache Iceberg. We can do both read and write operations on data lake, and also this will provide us the ACID transactions. If two or three analysts are continuously trying to access and modify the data on top of this data lake, it will provide a consistent view of the data which is being accessed. So that is what we call as ACID transactions. So the queries which analyst will be writing on top of this data lake will be ACID compliant. So instead of focusing on directory structure, the table formats like Iceberg focus on the list of files which is stored in this data lake. So say like if you have a table 1 and the data for this table is distributed across data lake in this location, that this Iceberg table format will be having the metadata information which is good enough to go and access these respective files. So it will keep track of that metadata information. And in the same way, if you have table 2, it is in some other different location. So this table format will be having the right metadata information to which this compute engine can go and access these files. Case of Hive Metastore, the definition of the table was based on the contents of directory, not on the individual data files. The modern data formats such as Apache Iceberg, Apache Data Lake, and Apache Hoodie all took this approach of defining tables as a canonical list of files, providing metadata for engines, informing which files make up the table, not which directories, which files make up the table. So this set of files is making the table 1 and this set of files is making table 2. So it will keep track of this metadata information about the list of the files, and it will help the compute engine to go and access the files. So that gives us the abstraction of a table. The user who is accessing the data which is stored in the data lake, he will be able to access that as a table with the abstraction provided by these table formats. So with this, we arrive at a new concept, that is data lakehouse. So data lakehouse gives us the capability of doing insert, else, update and delete operation directly on top of the data lake. So with these capabilities, we called that as a data lakehouse. So hope you're clear with this. So with this, I will close this lecture. So see you in the next one. Thank you.